So today and maybe the rest of the week, we are going to work on this section, talking about new handouts from old. So a lot of transformation things, composition things, all the stuff we can do with our functions. So first, let's refresh our transformation rules. What happens if you add something onto the end? How does it affect the graph?
Goes up. Oh yeah.
If you subtract something on the end, if you add it to the x,
Left.
and if you subtract it from the x,
Right.
if you multiply on the outside,
Vertical stretch.
or shrink, right? It would stretch it if it was bigger than 1 and shrink if it's less than 1. So it's like multiplying your height by a certain amount. Okay, if it's on the inside, it's horizontal.
I still like every time I do these, I see Miss Keller like in her room like stretch.
Sorry, it wasn't as dramatic.
No, it's okay.
Not as memorable.
Where's that slope to?
Inside does kind of the opposite. So if you're taking it times something bigger than 1, it's actually a horizontal shrink, and if it's smaller than 1, it's a horizontal stretch. What happens if you have a negative on the outside?
Left over Y.
Which one?
The Y.
X.
Why is it X?
If it's a negative on the outside, f of x is the same as y, right? So it's taking your y value and making it negative. So that flips it over to the x axis.
It's the Y. I was like negative.
It makes the y negative, but that goes across equal. And a negative on the inside.
It's over the Y.
Okay. So let's draw some functions and test our knowledge of transformations here. So I am going to start, what I always make you draw first?
Your graph.
The parent
Your
function.
parent function, yes.
Here.
So our parent this time is a square root of x. Can you do negatives? No. So the square root of 0 is? Square root of 1. What else can we do? 4. Square root of 4 is 2. If you wanted, you could do the square root of 9 is 3, and so forth. And we always made our parent function dashed. Alright, so then, what would the square root of x minus 2 do?
Move it down.
So if we go with each of our points down to square root of x minus 2 on the end. Really should look more curved. Okay. What if you have a minus 2 on the inside?
Right.
Okay, so it's taking our original graph, each point, right to. So either you're using colors or labeling beside it, or I'm doing both.
I have all these colors.
square root of x?
Flip it to the y-axis.
Okay, it's negative on the outside, so it basically does the square root of 4 and then makes that negative. So we still have the 0, 0, and it would be 1, negative 1, 4, negative 2, just reflecting across that x. And you could certainly draw, a different graph for everyone if you really wanted to. I'm being lazy and putting it all in one, but if that was too much, you could draw a new one. What's the 2 square root of x do?
You stretch it.
Stretch it. Basically, that's saying you take the square root and then multiply it by 2. So the square root of 0, 0 times 2 is still 0. Square root of 1 is 1 times 2 is 2. Square root of 4 is 2 times 2 is 4. And the final one. What's the square root of the opposite of x?
Flip it to the y.
So basically, in order to be able to do the square root, it has to be positive. So that means we're plugging in negative values. So the square root of 0, 0, if you put in a negative 1, the opposite of negative 1 is 1, so the square root of 1 is 1. Put in a negative 4, you get the square root of 4, which is 2.
I like how they connect the two reflections. No, the two reflections.
Oh, yes.
Man, I look like things happen right here.
All right. So far, so good? So now, let's say
Complete the square.
I asked you to use transformations to graph this function. Can you tell what our parent function would be?
A parabola.
Parabola, x squared. So 0 squared is 0. 1 squared is 1. 2 squared is 4. Negative 1 squared is 1. Negative 2 squared is 4. So this is my parent, and I always wanted you to have some exact points on that. But if I ask you the transformation here, this one, it's not obvious what it is. So, a little bit different, something we didn't do a ton of last year. If we can't look at it and know, we have to rewrite this. And so what we're actually going to do is use completing the square to rewrite this quadratic. Okay. So it's been a minute since we've done completing the square. So we started with, you were used to equations that were equal to 0. Since this is written in function form, it's a little bit different. So we're not actually going to move the c over. We're just going to group the x's together. Leave a little space, and I'm going to leave my plus 10 on the end. Okay. So a perfect square. Do you guys remember what we do?
Square.
Plus 9.
You take your middle term, divide that by 2 because we need 2 identical parentheses, and we square them because when you FOIL, you'll end up with that number squared. So 6 divided by 2 is 3, 3 squared is 9. Now here's where the difference comes in. When you're working with an equation where you're changing both sides, we would do plus 9 on each side. If I have a plus 9 here, what would I have to put out here to cancel it? Okay. Now this, we just made a perfect square, so it'll factor nicely. What multiplies to 9 and adds to 6? 3 and 3, so it'd be x plus 3 squared. inclinations to graph that?
Yes.
The plus 3 would move it,
Left 3.
and the plus 1?
Okay.
Get darker. I want you guys to do the next one. So complete the square. I don't even really care if you graph it.
You know me and variety. Yeah, I'm not graphing this. Never mind.
Yeah, this one's not so nice to graph, but I really just want to see if we can complete the square. So, middle term is negative 4. Divided by 2 is negative 2. Squared is positive 4. So you add 4, which means out here we have to
Subtract.
subtract 4. So what multiplies to positive 4 and adds to negative 4? Okay, so this graph would move right
to down 25.
down like that. Okay, one more. So if I group my x's,
We wouldn't get rid of them.
there's a minus 1 on the outside. So what is different about this one?
We have an A.
We have an A. Remember, completing the square requires your A to be 1. So when we did these last year, we usually just divided both sides by 2, but we're not working with two sides of an equation, so we can't do that. But what we could do is factor a 2 out of this parentheses. So it'd be x squared minus 3 halves x. And the minus 1 is still on the outside. If I multiply this out, I get back to my original problem. So I haven't changed it, I just rewrote it. So then we do our middle term, which was negative 3 halves. We have to divide that by 2 and then square it. What's negative 3 halves divided by 2? Remember, negative 3 halves divided by, this is like 2 over 1.
Oh,
So
you gotta flip it.
to divide fractions, you flip and multiply. So that's negative 3/4. And when you square that, that becomes
6 over 16.
not 6.
9 over 16.
So plus 9 over 16. Now here's where the trick really comes in.
Isn't it just 3/4?
We have to subtract that off out here, right?
Mm-hmm.
But I didn't really add 9 over 16 to my problem. Because if you start multiplying this out, you get a 2x squared minus 3x. You would have 9 over 16 times 2,
18 over 16.
which would reduce to 9
9.
over 8. So, because I had this 2 out in front, I had to think, okay, 2 times 9 over 16, that is equivalent to 9 over 8. So that's why I'm only subtracting the 9 over 8 on the outside. Okay, what multiplies to 9 over 16 and adds to negative 3 halves? Negative 1, so that's like negative 8 over 8 plus negative 9 over 8. And so there is my function factored. That one was not very pretty, but we got there. You could, but I'm really not concerned about the graphing as much here as I just wanted to work with completing the square. All right. Any questions about those? All right, let's look at this one. What's my parent function?
X. Absolute value of X.
Absolute value of x. So, absolute value of 0 is
Just the pointy one.
0. Absolute value of 1 is 1. 2, 2. Negative 1, 1. Negative 2, so remember the absolute value
V.
is a V. Okay, transformation. What will the plus 1 do?
Left one.
What will the negative outside do?
Flip it over the, yeah.
Okay. So if I flip 0, 0, it stays, then left 1. Flip this, comes down here, left 1, this, left 1. Okay, do we need more practice with transformations? I had a sign question on here, but I think I'm going to skip that one for now. And I want to actually go to example 5, talking about domains.
I don't know why I still thought it was stapled, so I tried to like open it, but it didn't. It just opened.
Alright, so I want to give the domain of, this means f times g, if f of x is 1 over x and g of x is the square root of x minus 1. So we have to think about each of these. If you have 1 over x, what's the domain of that?
One.
X.
X cannot be 0.
Okay. If I had the square root of x minus 1 and I wanted to find that domain, then we know x minus 1 would have to be,
Greater than or equal to 0.
so x is greater than or equal to 1. Okay, now if I want f times g, I have to put these two things together.
0.
If x is greater than 1, can it equal 0? Flush. So when I put them together, since I'm already only bigger than 1, we can kind of ignore the not equal to 0. So it's just everything larger than 1. So we're putting these together, looking for the overlap, the numbers that make both of them true. So if I want the domain of f plus 2, same thing, we have to look at each original domain. What's the domain of the square root of x? Okay. Over here, we would have to do
Greater than or equal to 2.
6 greater than or equal to 0. Subtract over the 2. When you divide by a negative, what happens?
It's flipping.
So x is less than or equal to 2. So I have to put these together. Think about what this means.
Anything smaller than
First one says everything bigger than 0. Second one says everything smaller than 2. So what numbers make both of them true?
0 to 2.
So only numbers between 0 and 2 would work. All right. One more. If I have f divided by g.
G has to be 0.
So if I think about f, x squared, divided by g, which is x minus 1. X squared, do I have any stipulations on that one?
No.
X minus 1, do we have any stipulations?
Cannot be 0.
Okay. So x minus 1 by itself isn't the problem, but when I divide them, now the denominator can't be 0, so that
X
means
can't
x
be
can't be 1. How do we write that?
Negative infinity to 1, 1, medium, 1 to infinity.
All right. So, practicing our domain rules as well as combining them in functions. Do you guys remember doing some of this last year? Do we need more domain? We will do some, but let's talk about compositions first.
Oh,
So I want to get through
I'm sorry, that was dramatic.
dramatic, a little bit of this, and then we'll see. We'll stop soon. Okay, here's f of x is x squared, g of x is x minus 3. When I say f composed with g, what does that mean?
Put the G into the X.
F of g of x. So g is x minus 3. I'm putting that into f. So function f is whatever we plug in squared. So the x minus 3 goes in. How would we square that?
4.
We get x squared minus 6x plus 9. Will you get the same thing if I ask for g composed with f? No, that flips it. So that's g of f of x. F was x squared. So now I'm plugging that into g. So we get,
X squared minus 3.
so with those compositions, remember your order matters. All right. I'm gonna do one more slide and then we'll stop for the day. All right. I want to use a table to find our compositions.
Oh, it's just like F when G of 1.
So, this first one represents what?
What F is when G is
Not,
No.
G isn't 1. What's 1?
1? X.
X. That's my X. So, that's saying we start on the inside. G of 1. So, it means when X is equal to 1, G is equal to what? So, when X is 1, G is
6.
6. So f of 6 is saying now x is 6. What's f equal to? 5. So my final answer is 5.
Wait, how did we get that?
And we started with the g of 1.
And that would give us 6.
So now we have f of
Oh, when
6.
F, okay, when X is 6, what is F?
Mhm. So g of f of 1. So start on the inside. F of 1. So it says when x is 1, what is f? 3. So g of 3 says now x is 3. What is g? 2. Are you guys seeing where I'm getting my numbers? So f of 1. So f of 1 is 3. And f of 3 is
4.
D. G of 1. So g of 1 is,
6.
and g of 6,
3.
g composed with f of 3. So that means g of f of 3. So when x is 3, f is 4. And when x is 4, g is 4. And the final question. F composed with g of 6. So when x is 6, G is, and when X is 3, F is, all right. We're stopping here today.